Okay, so we're going to look at, did you want to go?
No, go.
No, I'm going first. Okay, so we want to look at the vertex and axis of the graph of f of x equals 5 times x minus 1 squared minus 7. And it's not hard.
No, because this is in vertex form, which we can tell because of the parentheses and the squared and whatnot.
We love vertex form. And remember, inside those parentheses is the super secret opposite society. So instead of having -1, our vertex is actually going to have an x-coordinate of 1 and a y-coordinate of -7 because the people outside the parentheses just aren't as cool.
So V for vertex. The
V.
vertex of this is 1, -7. Whenever it says axis of the graph, it's talking about the axis of symmetry, not some other random axis.
The x-coordinate of the vertex.
And it's always going to be x equals, not always. In this chapter, it will always be x equals the x-coordinate, which was 1.
Yep.
Ta-da!
That's all there is to it. Piece of cake. Well, what about another one, you might ask? What about one where it's not in vertex form, you might ask? Well,
That formula, -b over 2a, we could use that.
we can, but you have to know the A, B's, and C's here.
It goes in order if your function is in order. X squared x and then your number, it goes in order. A, B, C, do, re, mi, it goes in order.
Do, re,
Like in the
do,
Southern music.
a deer,
Exactly.
a female. Okay. So
-b over 2a is what we want to find.
the opposite of -2 is 2, for those of you scoring at home.
Over 2 times a, so 2 times 4. 2 over 2 times 4, well, our 2's would cancel, and that would just be 1/4.
And if you don't cancel your 2's, you're going to have 2 over 8, which reduces
Also,
to 1/4.
yeah, it's
so
also
all the
1/4.
same.
So now, that's the x value of our vertex. If we plug that into our function, so plug in a 1/4, that'll tell us the y value.
You could get a fraction. Life is loaded with those. So if you're working out a problem in your textbook or some other place and you get a fraction value, don't automatically panic. We are in big school now where fractions do show up quite frequently.
As my graduate professors like to say, we're big kids. We can handle fractions.
And some of you guys have had it pounded into your heads that decimals are the way to go, and I will agree that
Who
there
in
are
the
times
world
when
would say that?
well, there are those that are there. By all means, use a decimal. However, on the non-calculator part of this test, you will want to use fractions because 1/2 times 1/2 is easier to do quick than 0.5 times 0.5. So Mrs. Stevenson is grinding out a problem for us right now.
I think we need some common denominators. So common denominator of 4, so times 2,
Yep.
times 2,
And a 6.
times 4, times 4. So that's 1/4 minus 2/4 plus 24/4, which is 23/4.
23/4.
23/4. That's the y value. So our vertex is 1/4, comma 23/4. Now that seemed like a lot of work. Mostly though that was because it was
Fractions.
a fraction. If we'd had a normal set of numbers, that would not have taken as long. That's the vertex.
Axis of symmetry.
Will be x equals our x value. And it asks us to rewrite the equation for the function in vertex form. So I'm pretty sure that this is how this works. We take the number that's in front of our x squared, stick that on the outside, then we plug in our vertex. That'll be x minus 1/4 because it's inside the parentheses. And then on the outside, we've got 23/4. That should be right?
I think that's how it should go.
Yeah,
So
so
you
there
can
you go.
always graph it and see.
let us know if it's not. So whatever.
You have to. Your good buddy completing the square makes an appearance now, and he's really, really super handy,
He is.
especially when you want to get into vertex form.
He can be hard to get along with sometimes. He can make your life a little difficult, but you just have to know how to deal with him, and then everything's fine.
Yeah.
So let's talk about it. Let's do completing the square.
Let's deal with it. And I like to refer to completing the square as one of my good German buddies that I used to teach with way back in the day, Dr. Hoffen squared. Because ultimately what you're going to end up doing is taking Hoff and squaring it. So one of the things that that helps the kids is the German reference part.
I see.
Hoffen
So
squared.
what you need to do is realize that by completing the square, we're trying to come up with something to stick in this blank so that we can factor this into the same thing twice, which is going to let us put a squared, and then we're going to end up with stuff on the outside as well. So we're trying to figure out what can I put here so that it factors evenly, and that's where Professor Hoffen square comes in.
Dr. Hoffen squared.
You always take this number 14, the number in front of x, you take 14 and you half it, and then you square it.
Hoffen squared.
So what we would put here is a plus 49. Now, am I just allowed to add stuff randomly to equations?
I'm pretty sure we have to follow rule number 72 of Algebra 1.
Which is that if I add something to one side of the equation, I need to also subtract it from that same side. Like somehow I have to keep it balanced. And so I can't just add 49, I also need to subtract 49. So we're going to stick that out here. Okay, I added 49, but I also subtracted 49. Together, those are 0, so I didn't
Nothing's
break the
different.
laws
Nothing's different.
of math.
And this is mistake number 4,372. It can show up quite frequently if you're not careful.
Right. So if I wanted to factor x squared plus 14x plus 49, I would have to say, well, what multiplies together to get 49 that adds to give me 14?
I would say 7.
7 and 7, right?
Yeah.
So that's how we're allowed to put it as one parentheses with the squared, because we're saying that this top part factors into x plus 7 times x plus 7, which is x plus 7 squared.
You might notice that 7 is also what we got half of.
Right. This number right here, this 7, should always end up being that 7 over there, which will save you some work if you remember that. We also need to come over here and figure out what 51 minus 49 is.
I know that one.
Yeah.
73.
Plus 2.
Okay, that was my second guess.
Yeah, so we've completed the square. Our function in vertex form is, in parentheses, x plus 7 squared plus 2. And then we can describe the graph of that function because this is a graph that we've shifted
7 units to the left and 2 units up. Pick the pen up, Mrs. Stevenson. Yikes.
Okay, thanks. Yes. Shift left 7, shift up 2. So let's,
hey, by the way, let's just, for kicks and giggles, the axis of symmetry on this one, could we identify that?
I believe that would be the x value of the vertex. So what is the vertex of this? We have to take the opposite of what's inside the parentheses, and we don't take the opposite of what's outside. So that means x would equal -7.
That's just pretty cool.
That is pretty cool. Are we done with this part?
Yeah, let's do the next one.
Okay, so obviously we can get more complicated with completing the square. It can't always be that simple.
If only.
What if we have a 2 here in front of our x squared? That's not going to work out. What we need to do is we need to say, okay.
Well, here's what we need to do. Dr. Hoffen squared is single.
Dr. Hoffen squared is single.
He only shows up around single folks. He is
single x squared.
Single x squared.
Not double x squareds.
He is not one to fly more than with just one x squared. So
that's good.
Yeah. So whatever is in front of the x squared has to be factored out so that we only have a single for Dr. Hoffen squared. What
we're going to do is we're going to factor out of these two terms that have x's, not the -19, which is convenient since -19 is not even. So if I factor out that 2, I get x squared plus 4x. And then I'm going to leave my blank because that's where completing the square is going to happen. And then the -19 is out here. And we're also going to have something that ends up there, just like in the last problem.
Rule number 75. Got to add and subtract at the same time on one side of an equation.
Okay, so we need to figure out what to put in here. We do that using this number in front of x. We do the Hoffen squared.
Hoffen, yep. We're going to take Hoff.
Take Hoff.
Square it.
And square it, which gives us 4. So if I add 4, we need to realize that what are we really adding if we add 4?
2 times 4.
2 times 4, which is 8. So
Last
out
check.
here, we need to subtract 8.
Brilliant.
Okay? And that's because this is not really a 4 that we just added because we stuck it in the parentheses. We have to do 2 times 4 and get that 8. We really added 8, so we're subtracting 8. That's like the biggest hang up with these kind of
It's a
completed
mistake
square problems.
that is easy to make until you kind of get comfortable with it.
So easy. So 2 times, we can factor this x squared plus 4x plus 4 into x plus 2 squared. Negative 19 minus 8 is minus
27.
27.
Got that one right. I'm
Yeah.
on that.
So-
Hey, and there we are in vertex form. Now, I prefer vertex form myself because when I look at a vertex form of a quadratic equation, I know exactly where I'm at.
Exactly.
It's difficult to see exactly what my graph is going to be doing when it's just in that general x squared plus x minus a number form. So, if we're really wanting to dig into a quadratic equation and check it out, always take the time to complete the square. Nice dig. Or you can be like volleyball dig.
Oh, okay. Yeah.
So anyway, but it always gives you an opportunity to see exactly where you need to go.
So we would shift left 2, down
Going down,
27, and then that 2 in the front, that's a vertical stretch of 2.
vertical stretch.
The way we do these problems, we are not really going to have to deal with horizontal stretches and shrinks because we want the 2 to be on the outside. We
That
just
is
completed
correct.
the square. So, vertical stretch of 2.
Fabulous. Okay, so we're going to write an equation of a quadratic function, and oh, by the way, it's got to go through these 2 points, one of them being the vertex. So, impossible, you might ask?
Definitely not impossible. This is quite possible because remember how we have that general vertex form from a previous slide?
General vertex form is so handy.
Well, the vertex is HK, right? And
No way.
They told us what the vertex was. It's HK. This point over here, now wouldn't that be considered an XY situation?
That would be. And here's the thing that the teenage brain struggles with. When they give you a point, they are literally giving you a value for X and a value for Y. And for whatever reason, sometimes that old teenage brain with pumpkin bread recipes and song lyrics and football plays.
You're really starting to get disconnected.
Yeah,
aren't you?
but it messes it all up. So
You know, when they're watching this, you'll be 40.
you're right. I will be.
You're a little
And
disconnected.
some gray hair right there.
Okay. Anyway, so we're going to put in, remember y and f of x are the same. So we're going to plug in hk, x, and y so that we can figure out what a needs to be.
And we have all those. Remember, f of x is actually your y coordinate. Gray hair.
Minus a negative 2. And did I get everything in right? Is that all the way it's supposed to
Negative
be?
27 and negative 4. I believe so.
Okay,
so. Yep.
so we just plugged in hk, x, and y. And so here inside my parentheses, remember we had ching chang walla walla bing bang, those are going to be pluses.
I like that.
Let's go ahead and let's add this 5 over.
Whoa, slow down, crazy woman, with these math skills.
Let's ignore that. Negative 27 plus 5 is negative 22.
You realize for all the OCD kids, you just created a point of reference that they will not be able to get over.
Oh, they'll be fine.
Okay,
Negative
that's
4
what I say.
plus 2 is negative 2
Squared.
squared. Don't forget to square it. Squaring's important.
And when you punch it into your calculator, because somebody's going to do this, negative 2 squared is not negative 4.
No, it's positive 4.
Totally
'cause
positive
You
4.
have to put it in parentheses and square it.
Yeah.
So negative 22 divided by 4, we can
11 over
simplify
2.
to negative 11 over 2.
Hey, a fraction.
That's okay. We don't mind fractions. So let's write this equation. F of x equals, we just figured out a is negative 11 halves. Now we want our x to be in there. X minus our h value, which was negative 2, so that's plus 2 squared. And then on the outside,
Minus 5.
So when you go back to write it, you do put in the vertex and you put in the a that you just found.
You need to leave your x and y alone when you rewrite the function for real, because we're trying to locate all the possible x and y's. We're not looking for just one specific anymore.
Yep. Linear correlation and modeling. So whenever we have real life data, we a lot of times try to approximate some kind of linear model that goes with it. And so one of the things we have with that when we come up with a linear equation is this correlation coefficient R. And whenever we find like a line of best fit on our calculator, that's something it gives us is an R, which tells us how good of a correlation it is.
The closer to 1 or -1 your R value is, the stronger the correlation, with 1 and -1 being perfect fits.
Right. If it's a positive number, there's a positive linear correlation. If it's a negative number, it's a negative linear correlation. If it's close to 1, it's strong. If it's or -1. Because it has absolute value there,
right.
And then if the closer it gets to 0, the weaker, or if it is like 0.00001 or something like that, there's basically no linear correlation.
None at all.
So we've got these pictures here as examples. Like, see how if I drew like a line of best fit here, which means the points are kind of equal on both sides, it's a line that approximates those values.
Like a linear straight line.
See how they would all be pretty close to that line? This is a strong positive linear correlation. But on this one, if I drew a line, then it would be like the points would not be as close. Like if I drew
Wow.
well, failure on my part of drawing a line. Now you
Draw
get to
a
make
good
fun of
line.
my lines.
That line is the most amazing line
See
I
how
have
the
ever
points are
seen.
kind of far away on either side, so that's going to make it be a weak positive, but it's positive because it's going up and to the right.
They generally trend up to the right.
Like, where would we draw this line? Like
No,
that?
no.
I mean, no, that's no correlation.
No,
That's
you
all
can't
kind of
draw
spread out.
all those lines on one
No.
graph.
So that's terrible, but that's negative and strong. This would be negative and weak.
And when you're using your calculator to find these different points of correlations, it will give you an R value when you perform the math on your calculator. So you don't have to try and figure that up on your own. That's
No,
not one we're going
no.
to say like, hey, determine the R value.
You just write it down from your calculator.
You just write it down from your calculator.
Bingo.
And we'll have a slide, like when we work out an example, we'll show you how to use your calculator to find those correlation
I believe
coefficients.
just in a moment, the next video they watch.
Shut the front door.
No, I will not.
Get out of town.
I also will not. Okay.
Okay.
Example 7. Draw a scatter plot of the data. Describe the strength and direction of the correlation between subscribers and average local monthly bill. So because it just asks us to look at the correlation between subscribers and average local monthly bill, we're just going to plot those two parts of our table.
Not using the years for
Yeah.
this particular question because they aren't asking about time at all.
Yeah. So that means that subscribers will be the X and average local monthly bill will be the Y.
I believe that is correct.
There it is, X and Y.
Yep.
So
Just like we said.
just like we said. So to draw a scatter plot, we've got like a little L shape here. We need to make some sort of scale. So put some tick marks on there, and then we'll have to figure out what to make our tick marks.
A comfortable amount. We want to be able to see everything from 69 to 158 on the X-axis.
Yeah, on the X-axis.
On the Y-axis, we'll want to see everything from 39 to 49. So the scale just might be a little different on X and Y.
And that's okay. Only whenever you really need to see like a one-to-one change do you really need to have that scale be the same.
If we just need a general idea of an equation, don't necessarily need the scales to match at all.
Yeah, so we picked to go up by 20 starting at 60 for the X, but for the Y's, we're going to start at 35 and go up by 5s. And then you just have to plot each of those points. We'll also show you how to do this on, as we speak, showing you how to do this on the
It's going on the calculator.
How to
We
plug it
are
in.
that good. Look,
Yeah.
look, no hands, no
but
hands.
there's
Calculator.
writing on the screen,
Mhm.
and there's calculating. Are there going to be two calculators? One
There
for the
will be,
84,
yes.
one for the
Yes, you can
Inspire?
see both right now. That's a
Yeah.
crazy. Why would you ask that? Can't you see them both right now, okay, Steve?
I can't.
Okay, well,
I
they're
mean,
there.
I can.
You
They're
can.
there.
They're there.
They're totally there.
They're totally there. And so back to the points here as we graph these.
It's approximate. I mean, 69.2, where in the world is that? It's approximately, where
Ish.
the dot is.
Right. And you'll also notice with scatter plotting, it's all approximately. Even your calculators may or may not have a little bit of error in the line they give you if you compare it with a friend. Lines of best fit are approximations.
Yeah. They have like formulas and stuff to come up with them though.
They do.
So,
They do.
So if you put in the exact same data in two different calculators,
Should match.
It should match.
Should match.
Because there's formulas and stuff. We're not going to talk about how to find those formulas because that's unpleasant, I feel like, to find an actual line of best fit. If I had to guess, having taken a stats course last semester, I would guess that would be unpleasant.
So I don't understand anything Ms. Stevenson just said because I'm putting mine on a calculator. Blah, 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 figured out myself. I don't know.
Okay, well, the calculator told us that the regression model for the data is y equals 0.122x plus 31.23. That's awkward that we didn't round to the same decimal place. I wonder what happened there.
We rounded to hundredths.
But then there were thousands. There's two different roundings going on.
Because that's what cool people do.
Let's talk about what's going on though.
So now we want to find what the price would be at 200 million subscribers.
Subscribers was X, so we put in the 200 for X.
Because we know that.
We know it. We want to know about 200 subscribers. So we plugged it in. We're working out the math right now. And so we end up with Y, which is the average local monthly bill, being $55.63. And there we have it.
Okay. Game
Signing
over.
off.